All right, guys, I think we'll get started. Hopefully you can hear me okay, and I think there's going to be a few more people that are gonna join. So on the off chance you haven't met me, my name is Armin Kokosh. I lead a firm called Rebology Analytics, where we specialize in revenue growth analytics, so primarily margin analytics optimization, promotion optimization, and then customer analytics. So what I've done for most of my career as a practitioner, as an executive, building teams across industries, and I help companies essentially do the same thing now as an advisor for a little over a year and a half. So I do these webinars. They're almost always ad lib, but I tend to do these about once a month, and we have some really good engagement. And so what we'll talk about today is just sort of leveraging ChatGPT for sort of key revenue growth analytics tasks, right? And so the examples I'll actually go through is price elasticity modeling. We'll do a cohort analysis, and we'll get a brief intro in churn modeling, right? And so I'll share some examples. I'll share some code. I'll send out this presentation along with the actual code that has been generated by ChatGPT, obviously with my refinement. But you'll all have that, right? As after this call, hopefully by this weekend or by Monday. So let's get into the content real quick. And if you have any questions, guys, there's a chat button, I believe, on the webinar, or a Q&A button. So just click on the Q&A. Ask me anything during this webinar. It's going to be very, very sort of informal. So if you haven't met me before, we talked about Rebology Analytics. There's really three areas that we kind of focus on, and the intent is really just to sort of help companies build these capabilities organically in a way that sort of aligns with the operating rhythm of their sales teams and marketing teams, and in a way that's sort of sustainable, right? Their existing teams can maintain it, so there's no sort of reliance on outside vendors and things like that. And so I'm going to skip a couple of these pages just out of interest for time, but I'll send these to you as well. But let's get into the content, right? ChatGPT has just been sort of the craze, right? And everybody is, all of a sudden sort of a large language model expert on LinkedIn and things like that. And so I fully realize the hype kind of surrounding this, but at the same time, it's incredibly helpful for sort of analytics productivity efforts, right? And so I found ChatGPT in particular, but also other kind of derivations of large language model based tools like GitHub Copilot, or you have, I think, Claude 2, which is a slightly weaker version of ChatGPT. They're incredibly helpful in speeding up your analytics work streams, right? And we're talking about being able to do things in, a matter of sort of, minutes, or maybe kind of, single digit hours that otherwise took you, a couple of days to figure out, right? Through sort of trial and error, unless you're really, really good, right? Which I'm certainly not. And so I think we're sort of entering this area where, these capabilities, right, can really sort of augment an analyst's work stream. And so really what I want you to walk away after today is just get a glimpse of how this can really help in your work streams. Whether you're doing analytical tasks, whether you're in a revenue management team, or you're doing digital analytics, et cetera, or you're an executive leading these teams, just recognize the fact that there's these capabilities out there that can make your team just a whole lot more productive, right? So I'm not going to spend too much time with GPT-4 just because I think it's been sort of proselytized a lot, sort of in social media and things like that. But that's really kind of the latest version that ChatGPT is built on. It's built on this large language model, which is just a fancy natural language processing model called GPT-4. And so, what it can really do for the purpose of our discussion, right? It can work with just a large amounts of raw data, as long as it's structured, and it can help you with sort of very foundational analytics tasks like sentiment analysis, classifying text, summarization, building predictive models, et cetera, et cetera. You have to have obviously really good grounding in the domain that you're operating in and the industry, and you have to have some, fairly decent coding background, right? Otherwise, you'll just sort of take the wrong answers at face value versus being able to sort of critique them. But having said that, right, it's able to help you with these tasks immensely, right? And so the beauty of it is it's sort of, industry and sort of domain agnostic, right? It can really help with analytics efforts across kind of RGM and finance and marketing and sales. And so it can really kind of make those functional teams a lot more productive. So just wanted to give you a sense for just how big GPT-4 is. This may not be sort of readily available in a lot of the publications that you tend to see, but it's a huge model, right? It has almost 2 trillion parameters. That's trillion, right? Not B, but T. And it has about 120 layers. It's about 10 times bigger than GPT-3, which was the initial version of ChatGPT, right? Trained on roughly 13 trillion tokens, both text as well as code, right? So it's important to recognize it was also trained on just a ton of coding data. And it especially does a really good job in sort of foundational programming languages like Python or SQL, maybe some JavaScript and things like that, right? Even R, right? It actually does a really good job of kind of building R scripts. The training data they use, it's sort of, very commonplace data, but it's a bunch of data that's been crawled from the web, along with, things like Twitter and Reddit and YouTube and, maybe some GitHub and some online textbooks, right? But it costs about $63 million to actually build it, right? So that's kind of the computational power and the training time. The one thing that I'll kind of emphasize to you guys on the off chance you haven't used it, although it's, again, widely sort of available, is Quote Interpreter, right? So for a lot of tasks that you tend to do in companies, or that you want to, again, build a marketing mix model, you want to build a churn model or a cross-sell propensity model for your customers, right? You can use Quote Interpreter for that. And that's what you see on the right side is sort of how it looks like. We'll do a quick demo, but this is sort of how it looks like. It's a plugin for ChatGPT, right? And so it works very simple, right? You upload a structured data set and you give it prompts. The caveat that I'll sort of emphasize for you guys, especially those that that work in larger corporations, or really any company, right, is don't upload sensitive data, right? Or in that sense, don't upload any sort of company data. Always work with simulated data, right? So what I tend to do when I need some productivity bumps is I sort of simulate a fake data set that looks and feels like the data set that we tend to work with for one of our clients. And sort of get help or get, sort of some additional kickstart using that simulated data set, right? Never, ever actually upload real data. The way you sort of leverage GPT and ChatGPT, right, for sort of this analytical productivity is you have to be incredibly clear and sort of articulating what you want to accomplish. And you want to give it plenty of context, right? That's written in a very structured manner. And so, for example, there's a high level kind of churn prediction, right? One of the prompts would be, here's a data set, analyze this customer data that I've sort of uploaded and predict which customers will likely churn in the next quarter. I also want you to present the top 10 customers with greater than $10 million in fiscal 2022 sales with the highest probability of churn. Oh, and by the way, because we have to explain this to the sales executives and maybe our sales teams, be very specific about what factors actually contributed to their high churn probability, right? So you have to be, fairly specific in what you want to accomplish, down to the actual format that you want the output to be. And again, this is like a very, very short example. We'll go through a much more sort of expansive prompt set for that. Thank you for the question. Somebody asked a question. If you don't mind, let me go through some of these, couple of these slides, and I'll address it. Again, in terms of tailoring, definitely tailor it to the particular domain that you're working in. So if you're working on a price analytics exercise, right, tailor the prompt for that particular domain, which is revenue management, which is pricing, right? If you're if you need sort of a kickstart to build, some marketing analytics model or some customer model, again, work within the context of that particular domain and be very clear about communicating what domain that is, right? And so an example for price elasticity, right, it would be like, hey, based on the following sales and pricing data, calculate the price elasticity of demand for each product using a log regression regularization, right? So it's not enough to just say, hey, tell me what the price elasticities are for this data. Be a lot more specific when you actually plot it. So I'm simply sort of summarizing, some of the key highlights that I think you should know and you should kind of practice when you give these prompts. The one thing that I'll tell you is it won't be 100% correct for sort of more complex analytical tasks. And when I say complex, we're still talking sort of foundational analytics, even if it's like foundational machine learning models like a random forest or like gradient boosting, right? These are all like fairly kind of vanilla things, at least nowadays. But it won't get it 100% right? And so you likely need 2, 3, 4 times of sort of additional prodding and additional kind of clarifying prompts before you actually get the right answer. Somebody has a question, curious how accurate you think responses are versus hallucinations. I found good help with code questions, but very low accuracy with asking for interpreted analysis from data sets. It is wrong more than right. I feel like it is very early for using code interpreter, really using it. Yeah, I think it's a really fair question. I think I agree with you. I think code interpreter and even ChatGPT in general, right? It's much more useful for kind of getting you kickstarted on the actual analytical effort, meaning with the coding itself, as it is about sort of interpreting the results 100%. And I think that's actually a really, really good question. So definitely use it more to sort of speed up and enhance the productivity of the actual analytical tasks, as opposed to using it to create the insights and the executive report. All of you guys will have plenty of domain expertise and industry expertise to do it yourself. And by the way, right, like if the current trends continue of sort of leveraging LLMs for work tasks and analytical tasks, we're going to become a really, really dumb workforce, right? Like you don't actually learn by kind of leveraging the output of these things. It's a really good question, because you're right. Like there's a ton of hallucinations going on with these LLMs, but coding tends to be a lot more binary, right? So in that sense, you have less room for hallucinations. The other piece that I want to point it out, and I saw this actually earlier today, but I wanted to show it to you guys. I just want to emphasize, like, use your domain knowledge, right? And actually use your existing kind of analytical skills, especially if you have coding skills, right? To kind of review what GPT is telling you, right? The only thing that we're using it for now, again, is to just speed up our productivity, right? And cut down the time of like figuring out what syntax to use and what, script and whatever else. It sort of really helps us with that, but like use your actual experience. And so what we tend to see now is there's this, sort of barrage of, people just sort of copying and pasting ChatGPT content on LinkedIn, right? Like blindly. And so what a gentleman named Rich Hyman actually posted today is kind of gave like 3 or 4 examples. I redacted the names and the kind of the faces here, but if you look closely, right, a bunch of people copying and pasting ChatGPT output as if it's their own sort of LinkedIn post, right? And so in fact, if you guys go to LinkedIn and look for search for regenerated response and click on posts, you'll see just hordes of posts from anywhere from analysts to even senior executives, COOs, et cetera, who are just sort of blindly copying and pasting content. And by the way, the one of the side notes that I included, because I think it's really appropriate and kind of in this age of like overhyped AI. Rich actually has a good book. He didn't ask me to kind of share this in the webinar, but I think it's a really good book. It's called Doing AI. And so the fundamental premise behind that is, like AI and ML has been so overhyped, and sure, generative AI is really cool, and kind of helpful in particular narrow domains. But we've had this kind of pandemic over the last decades where like companies are trying to find problems that kind of fit the solutions, right? The AI and ML solutions that they've been sold on by whatever consulting firms and publications, et cetera, as opposed to applying the right sort of solution to problems that actually matter for customers in the company. And most of the time, that's not AI or that's not ML, right? Like most of the time, simple things can actually solve fundamental problems in companies as opposed to relying on AI. So it's a really good book, highly encourage it. So let's talk about price elasticity modeling. We actually go through an example of kind of doing this with Code Interpreter. And again, going back to the initial comment was like, we're not going to use it for sort of insights. We're going to use it to just sort of build the code that helps us model price elasticities, right? And so for those of you that may not know price elasticity, is just simply a measure to sort of understand how much is our unit sales or demand changing if we actually change price up or down. It's mostly a negative number. There's some industries like luxury and maybe some finance goods that are sort of positive, meaning you can change price up 10, 20, 30%, and demand is still going to be sort of static. But it really helps us understand price sensitivity. And for a long time, things like price elasticity modeling was really the domain of specialist consultancies and large information providers like Nielsen and IRI, who would charge six figures, right? I mean, to like do price elasticity models off of sort of retail and syndicated and CPG data. And nowadays, right, if you have the data, even aggregated data, you can do it yourself, right? Especially through the help of sort of LLM that we're going to talk about. I'm going to skip over the slide, but it just gives you more context. If you haven't necessarily worked in revenue management, it gives you more context why it's actually important to know price elasticities, right? It's actually a really fundamental thing that companies should know. The one thing that I'll just sort of show you guys, and you'll have this content. I'll send it out to you, but it's sort of a my assessment, at least it's somewhat of a biased assessment. My assessment of what sort of models should you ideally use by industry to actually estimate price elasticities? Like for industries like retail and CPG, they're fairly kind of linear relationships, a ton of transactions, kind of small prices, high volumes. You can actually use forms of like more advanced forms of regression. You don't need to be sort of that complicated. When you get into things like wholesalers and maybe some manufacturers where sales are a lot more kind of sporadic, and there's like this hockey stick in terms of assortment distribution, that's where you may need to kind of use some more advanced machine learning models, right? But let's actually talk about the prompt, right? So I want to create a price elasticity model for my company, right? And I want to use ChatGPT, and I'm going to use Code Interpreter in this case, right? Where I uploaded my structured data set. It's a simulated data set because I didn't upload company data. And so this is literally what I'm telling ChatGPT to do. I'm defining what the actual task is. It's a retail price elasticity. What is the context? Well, the context is we have this weekly data set for this retail company. We want to analyze the price elasticity. What does the data contain, right? So you actually kind of spell out what the variables are and what they mean. And you kind of specify an objective. I want to calculate price elasticities. By the way, I hate R and I want to do it in Python. And I really think we should use ElasticNet. It's a form of regularized regression. And I want to evaluate the price elasticities by store, product group, and the combination of both, right? Because that'll help influence, maybe merchandising tactics, promotional tactics, et cetera, et cetera. And then I specify some additional details, right? So like, how do I define average price? Should I use the absolute values of units and price, or should I convert it to log value? So give some additional details that you want ChatGPT to consider in your model. You want to optimize that model, right? So things like regularization, right? They work with primarily two parameters. One is called alpha, then one is called L1 ratio. But at a high level, they sort of control the extent that the regression model is going to reduce the importance of the variable, right? How close is it going to get it to zero, or perhaps zero? It's really useful for anytime you work with data sets that have high collinearity, which is honestly most kind of commercial data sets, like most kind of pricing and marketing problems, you have a bunch of variables that are highly correlated. So you use regularization, right? So we're going to feed it like, 20 or 10 values for each of those parameters, and we'll let the model decide through cross-validation which one's the best one in terms of the model result, right? And finally, I tell it to build the model, right? And how do I want the model to look like, and how do I want the coding structure to look like? And so what I'm telling ChatGPT is, don't just give me a bunch of random code. Actually create a modeling function, right? That will run the hyperparameter optimization, that I can actually apply the best model that you come up with for each sort of combination of these store and product groups, right? So create a function that I can apply to the groups in a very sort of seamless manner. And the last piece, which again, take this with a grain of salt, right? I sort of included this as maybe an interesting exercise, but like, you can prompt it to create some like high-level insights. So create an executive report, perform some store analysis. Tell me which stores are the most or the least price elastic. Give me some visualizations, right? Tell me what the revenue impact is going to be, right? And again, like the caveat on these things, like, yes, there's going to be hallucinations involved. And so I would encourage you guys to just mainly do this as a sort of interesting intellectual exercise. Don't take this as face value and like, copy and paste it and send it to your executives, especially not copy and paste the regenerate response button. Okay, so somebody asked, how worried should we be about privacy when uploading data to ChatGPT? Yeah, 100%. So privacy is a real thing. Any data set, any question that you ask of ChatGPT, it will be used to kind of refine these large language models on an ongoing basis. And so that, that's why, always work with simulated data. And so what you can even do is, if you have a data set that you want to kind of build a model off of, and if it's your company data set, right, you can actually ask ChatGPT to just, build you a simulated data set that looks like this. These are the variables that I want. And I'll give you some Python or some R code, right, to actually kind of create that simulated data set, and then upload that simulated data set to go through the exercise. And guess what? The actual code that it sort of gives you, you can kind of use that as the framework to then kind of build your model off of your real data, right? It's a really good question, and so we should all take that really, really seriously. So let me just kind of demonstrate what the output is, right? So I've kind of given that prompt, and by the way, the way this looks like mechanically, on the off chance that you haven't done this, right? So if you look at, if you go to ChatGPT, let me just copy my prompt real quick. So this is exactly what we talked about in the example, right? This is the actual prompt that we're going to feed. If you go to ChatGPT, and by the way, whoever has the last question, like notice I routinely clear out my chat history, right? It's like I do this pretty much every day at the end of the day. Like I don't want any history to kind of remain there. And I only use simulated data. But if you go to ChatGPT, if you go to this GPT-4 section, there's a plugin called Code Interpreter, right? So you select that off of this dropdown, and this is where you can actually upload the data set. So notice I'm using a simulated data set, and this is where you give it prompts, right? And so you just copy and paste it in there, and you kind of feed it into ChatGPT. And it's going to start doing its work. And the first thing that it's going to start doing is sort of, kind of reinterpreting or kind of summarizing what your directions have been. And then it's going to go through the coding exercise. And so let me show you the actual output versus kind of waiting for this to finish just for the sake of time. And again, keep in mind, this is something that I've kind of reviewed and had to kind of go through three or four kind of iterations to fix it. But it gives you a really sort of neat, well-structured code that you can actually run a price elasticity model, right? So right off the bat, right, you can kind of notice, and it's invoking the right libraries, right? It's doing some text cleaning, reading in the data. This is how our data looks like, right? This is right, net sales by product and by store. Like it's a fairly simple sort of simulated data set. Does some data munging, and this actually creates the price elasticity function, right? It uses Elastic Net. And notice, right, it actually calls out appropriately the feature that we're gonna sort of predict. or one of the features that we're going to use, one of the main features is lock price. We're also going to use some categorical features, right, for time series. We're going to create dummy variables off of this, right? So it does the one-hot encoding appropriately. Notice the parameter values regularization. It kind of feeds it in there, the values that we specified. It builds the model. Remember, we told it to build a 10-fold cross-validation. And so it does that, and it takes advantage of parallelization, right? So I happen to be using this on my GCP cloud instance. So you can certainly parallelize the optimization of this model. Okay, and then finally, there's a couple of things that it does. One, we're using scaled values, right? So always use scaled values when you build a regularized regression model. And so what it does, it sort of kind of descales the coefficients and like puts it in the actual kind of normal range. The log price coefficient is what we're interested in, because de facto that's what sort of that's what's analogous to price elasticity anytime you run sort of a log regression. And it's going to create a data frame, right? So data frame is going to be but by the way, before the data frame is created, it creates the function. We apply the function to a group data. Notice I grouped my data by product group and store name. And so within those groups, we have the variables that the function is going to model off of, things like log price and the seasonality variables. And it gives me the output, right? And again, it's simulated data, so pay less attention. There's a bunch of elasticities that are sort of 0, and anything that's really kind of less than -1. That means it's inelastic, but you have some stores and categories that are highly elastic, right? But again, it did a pretty decent job of creating a model that's usable, right? And again, like you'll have to spend some more time in sort of refining it. But in past days, this would take like day to just kind of figure out what sort of model to build and how to optimize. But you can actually do this nowadays in minutes. Someone else asked another good question, more of a general question. You have previously written about industry margin pools. Do you think GPT could help with that for specific industries? That one's that one's a little bit tricky. I think it's a really good question, but I think the actual construction of sort of margin pools, it's a really simple exercise, right? The hard part is less about kind of building the actual analysis. The hard part is actually kind of obtaining the data that allows you to do the industry margin pools, right? Because you'll have to get right, if you're in a 3-tier system, you're a manufacturer, you have to get like distributor data. Ideally, you have to get sell-through data, and all these things are kind of available, right? But then you have your own data, the sell-in data to the distributors, but sometimes you sell directly to the end customer, which could be either a consumer or a retailer. And so I'm giving you a really long-winded answer, but in a way, it could maybe help you with the actual data engineering piece and kind of kickstart that. So I think that's maybe plausible. I would just be I would be more worried about hallucinations there. But I think with the actual data engineering piece, like, hey, I have these 4 different data sets for my sell-in data, my distributor sell out, my retailer sales to consumers, and their prices and costs and sales units. And this is what I want to do. Give that a try, right, and see what sort of code it gives you for the data munging. But that's such a much more manual type of analysis that for that one you really kind of have to pay attention to. So let's go back to really good question, by the way. Appreciate all the questions, guys. Let's talk about cohort analysis. And before I do that, I'm going to take a swig of my energy drink, because I have 2 little kids and I'm tired most of the time, and we're gearing up to go to Disney World next week. And so I'm already tired before going to Disney World for a week. So I'm talking about cohort analysis, right? So we did price elasticity modeling, cohort analysis. It's a fairly kind of basic principle, right? But it's a kind of a blurry image. I'll show you an actual example off of simulated data. But at a high level, what cohort analysis measures is for a group of customers, and you can define the group however you want. Could be a temporal definition. One cohort could be on the left side, if you can see this image, customers that joined us, the week of May 18th, or a group of customers that joined us the week of May 25th, right? That could be a cohort. A cohort could be, customer segments, right? A cohort could be, particular customers that joined in a given year or a given quarter, whatever. Could be customers that were generated by different salespeople, and you want to understand their behavior over time to see if there's anything sort of interesting that you can determine through kind of the customer management strategies of your sales team. But really what it measures is, at a high level, retention rates over time, right? So the way you interpret this particular kind of example chart is people that joined the week of April 27th, a week later, only 22% of them remained. Whatever the remain means, right? It could be website visitors, only 22% visited the website again. It could be, users of some particular SaaS product. Week 2, 19% remain. And all the way to week 17, you have only 6% of the customers remained, right? So that's what cohort analysis does. It's actually really useful for, B2B companies, as well as B2C companies, right? Particularly, things like subscription products. It's very useful for nonprofits, right? So any sort of donor-based businesses where you want to evaluate their behavioral patterns and life cycles and see how retentions over time have changed, things like that. It's actually a really, really useful, but very simple sort of revenue analytics concept. And so we need to build one of these. We're going to use simulated data, and we need to build it today. But you're also working on another engagement where your boss asks you to attend these, 3 meetings or whatnot. So you're going to go to ChatGPT to kind of speed up the effort, right? And so again, the prompt is very detailed. I want a cohort analysis for a distributor. What I want to do, I want you to design a Python script that conducts an annual cohort analysis on the provided simulated data for an automotive distributor. So I even specify the particular industry domain, right? I want you to conduct the cohort analysis overall and actually kind of delineated by customer segment, okay? I give it a description. So what does my data look like? Very similar to what we've done with the price elasticity modeling. And we build the prompt, right? And so I actually specify, like, how do I want you to determine the cohorts? Well, define the cohorts based on the year a customer made their first purchase, right? Simple enough, right? So each yearly cohort is when the customer made their first purchase. What do I want to kind of, what do I want the output to look like? Well, I want to look at the number of active customers for each of the ongoing years, right? I also want to look at total revenue, and I also want to look at average revenue per customer to see if there's any sort of weighted average revenue declines per customer or not. And what do I want the outcome to, or the output to look like? I want it to be a sort of a structured table format with these columns, right? And actually specify what tables I wanted to create. So I'm not going to go through the details, but if you look at the structure of the prompt, it's super detailed, right? Like, this is what I want it to look like. This is what I want you to call the function that creates this table. This is what I want to measure, customer retention, which is simply the number of active customers in each of the following years relative to the year of joining, right? The year of joining, year 0, will always be 100% retention, and it will sort of monotonically decline. And then lastly, I also want to do a revenue-based cohort analysis. So I may have a really, really, crappy customer retention, but maybe my revenue retention is really good. So I'm losing, unprofitable customers or really low volume customers, but I'm actually retaining the customers that generate a bulk of my business. So who cares if my customer retention is that bad when I'm retaining, 99% of my revenue, okay? And then the last piece, right, I wanted to create some visualizations and things like that. I think, again, going back to the earlier question about hallucinations, right? Like, this prompt about the kind of the insights or the actual visualization, requires less sort of creativity, less domain knowledge. I think there's probably less of a chance to actually get into some false positive, because this is a really sort of concrete ask to visualize X, Y, Z that you actually spell out, right? So I think there's less of a chance for ambiguity there. Okay. So I'll show you guys a demo, and let's see what that looks like. So if I go back to my script, hopefully you guys can see this. If not, I can certainly enlarge it. But there's one more question. Will the prompts you mentioned work with the without the quote interpreter, meaning ChatGPT 3.5? Yeah, I mean, it certainly does. I mean, so the question is, right, can you actually do this without using quote interpreter? Absolutely, you can. You can literally just like copy and paste the simulated data, like copy and paste like the first 10 rows, and it'll work. The GPT 3.5, right? It's a much smaller model, right? It's nowhere near as extensive. So you're going to have like more more creative freedom in the outputs. Like you'll have more hallucinations. It's going to be less accurate. It'll require more prodding. I definitely encourage you to use GPT-4 if you can. But having said that, you can do that again just in kind of plain vanilla GPT, just by copying and pasting the first few rows. But really good question. Let's look at the actual output, right? So we're interested in how customer behavior changes over time for this automotive distributor based on anchoring to the year that the customer joined, right? And so again, what you see here is the responses that ChatGPT gives back, right? So this is not my sort of verbiage. This is the output of the actual quote interpreter kind of interaction, right? So we're going to load pandas, right? We're going to use that for data munging. We're going to use some visualization libraries. This is how the data set looks like, right? We have a customer number, we have net sales, we have a customer segment, we have a year, okay? Next, we're going to determine the cohort. What is our cohort? Our cohort is when the customer first joined, right? So you'll see that this particular cohort year is 2018 throughout. And this is simply for the same customer, their net sales in each of the subsequent years, right? So they joined in 2018. This is our net sales in 2018. This is net sales in 2019, et cetera, right? And so what we're interested in measuring each of these cohort years, how our customer retention changes over time, and see if there's any interesting patterns that we can observe, right? This is the function, right? I've asked it to sort of modularize the function, just create a function that I can apply to the actual data versus having to go through kind of several iterations of calculations of different versions of the actual data frame. And so it created a function that kind of looks good at initial observation. You can always kind of run the code and see if it gives you something that's intuitive and aligns with what you want it to do. And so this is kind of a glimpse of what the data set looks like, right? So you'll see this is the cohort year 2018. This is the year number, meaning year 0 is always kind of the year that the customer joined. Year 1 is the next year, which should be 2019. Year 2 is 2020, and so forth. And so you'll notice it measures customer retention. Year 0, you're going to have 100%, right? Because you're measuring the year that the customer joined. Year 1, we're only retaining 34% of the customers, right? In year 2, only 28 or 29% of the customers remain that joined in 2018, right? And we can kind of measure the same thing for revenue as well, right? And there's some additional functions around doing the cohort analysis by segments. So again, we want to do the same thing, but segmented out by the various customer segments that we have. And we want to look at revenue retention. So again, notice the same number, right? So I think the customer retention figure may have been 35%. Revenue retention is more like 60%, right? So we're losing customers. It's still an alarming figure because you're losing like 40% of your revenue of those customers that joined last year. You're losing 40% of that year, but you tend to be losing, more unprofitable, more sort of low ticket or low volume customers, right? Having said that, it's still a problem that you need to address. And the last sort of function that measures revenue retention, but this time by customer segment, okay? And I've asked it to visualize it, right? And again, it was a fairly sort of, well-structured prompt, very sort of binary output. So it did what it's supposed to do. It's a very simple visualization that looks at customer retention by cohort year. And the way you look at it, right, is you have the cohort year over here. So people that joined in 2018, people that joined in 2019, et cetera. And we look at what their retention is over the years. So look at customers that joined in 2018. We only retained 34% of them in year 1, 29% in year 2. By the time we hit year 4, which would be fiscal year 2022, we've lost 80% of them, right? Some of these numbers are lower because I think my simulated data goes through like halfway of 23. But notice a couple of things that we can kind of easily determine. One, there's a kind of a decent decline in customers, right? over time. So we have a retention issue as we go out in the out years. So what do? Do we have any mechanism to provide a list of customers that have a high probability to churn to our sales team that they can act on? Do we have that? No. Maybe we should think about sort of doing that. The other thing is, if you look at just the year one retention of customers, in 2019 we retained 34% of the customers that joined in 2018. But in 2020, we only retained 29% of the customers that joined in 2019. In 2021, if you can see my cursor, we only retained 21% of the customers that joined in 2020. Obviously, I know COVID and things like that could have played a part, but these numbers are declining, right? So we not only have a retention issue over time, but we also have a year one retention issue as the years have progressed, and we're doing a lot worse, now versus how we've done in the past, which was more like 34% year one retention. So again, what do we have to do differently, right? Do we have to do more surgical marketing? Do we have to do white glove service for their more valuable customers? But like, this is a really sort of simple but fundamental analysis that I think more and more sales teams need to use. At least I haven't seen a wide adoption of this in B2B settings, but I think it's really important. And then revenue retention, right? It's a very sort of, different, there are different numbers, right? The numbers are higher because you tend to lose kind of lower profitability customers, but similar trends, right? You're retaining 60% of the revenue from the customers that you've sort of acquired in 2018. But in 2020, it's a little bit less. But in 2021, it's way worse, right? And then in 2022, looking at the 2021 cohort, it's also much worse, right? So if you look at just year over year, how year one retention changes, we're doing a lot worse as a company, right? So we have a real customer retention issue and a revenue retention issue that we need to figure out how to sort of mitigate, right? I'm not going to go through these examples, but it does it by customer segment. And so again, the actual insights are less exciting in a literal sense because it's simulated data, but you kind of get the sense of where this type of analysis can go. Okay. The last piece, guys, and I'm not going to go into too much detail, but churn modeling, right? So again, I'll skip the basics because I think most of you guys will know what churn modeling is. But I think there's still sort of a substantial segment of especially B2B companies that just don't really do a good job of doing predictive churn modeling, right? Especially in a way that sort of integrates with CRM systems, that really kind of serves up high probability churn customers that also have a high sort of lifetime value, and serves those up to the sales team, really articulates why the model thinks the customer is going to churn in a way that makes sense to the salesperson, and sort of prioritizes the outreach and the appointments for those particular customers. So again, like it's becoming more popular, but there's still just a high portion of companies that don't do this really well. And so we've actually done a survey of about 150 or so commercial leaders. Some of you actually have taken the survey that are on this call. So thank you for that. But we had a really good response rates, and we really kind of surveyed people that kind of lead pricing teams, that lead marketing teams, sales teams, et cetera, analytics teams, like just how strong are they in a lot of these revenue growth analytics capabilities. And so, I mean, honestly, the results were like, sure, they were alarming, but it was also sort of aligns with what I've seen in companies, both as sort of kind of leading these functions and also advising companies. Like there's a big, huge gap, particularly for traditional B2B companies. So distribution, manufacturing, tech tends to be pretty good, but there's a huge opportunity to actually build these capabilities. And honestly, you can build these capabilities nowadays in-house for the most part, especially if you're a mid-market company, just kind of using tools that are already at your disposal, right? And so, so I would just encourage you guys, if you work for companies that don't have sort of, predictive customer churn, predictive, cross-sell, cohort analysis, RF analysis, like if these capabilities don't exist in a really seamless, easily accessible manner for your sales and marketing teams, like start doing them, because it's really kind of low effort, but really sort of high value, especially when you do it in a way that makes sense for the commercial teams. Okay. Another question in industrial B2B, can we define churn as a drop in volume rather than a customer not buying from us anymore? Yeah, absolutely. I think so you definitely have that issue, not just in industrial B2B, but you have that in like med tech, where you still retain the customer, but like they already purchased that really expensive set of 3D machines a couple of years ago, and now they're just like purchasing really small kind of low ticket stuff, and so you don't have a customer retention issue, you have a revenue retention issue. So yeah, in that case, you need to use the revenue retention, right? And so I think that's the method that is the most meaningful. But honestly, I would couple that with kind of a gross profit drivers analysis, right? We actually decompose the year-over-year difference in your profit into like volume, customer mix, product mix, price, things like that. I think that's where you can get some really good insights as you kind of peel back the onion. Okay, really good question. And so on the churn piece, I'm not going to go through the actual example, but I wrote this up for you guys just to kind of illustrate like how a prompt should look like when you actually give it to ChatGPT. And the one tip that I'll give you guys, right, is you plan to use this to sort of enhance your productivity, and you're like, man, I don't want to spend like 45 minutes crafting the perfect prompt. Describe what you want to do. Doesn't have to be well structured, and feed it to ChatGPT. And it's like, hey, give me create a well-structured prompt with these categories based on this text that I just copied, in a way that you can best interpret it to kind of give me the coding output. Feed it in there, it'll return something for you. You'll have to modify it, but again, it'll speed up that creative process where you actually work on the prompt itself. Okay, so last comment, and by the way, guys, I want to make sure that you guys get like 5 minutes, so finish maybe a little bit early. But so if you have any more questions, just please feel free to put it in the chat box. Somebody commented, completely agree with you. We're trying to build an elasticity analysis with manufacturer companies like us sell to dealers, and then dealers sell to the end customers. Yep, very familiar. So there would be an elasticity with the dealers and another elasticity with the end customers. Yep. Also, when there are price increases, dealers tend to pre-buy with old prices, and hence there's a peak that adds further complications. Absolutely, right? Like we see this all the time. This is like very prevalent in like hardline manufacturing. This is very prevalent, I think, in likely in some kind of industrial businesses. It's very prevalent in med tech, right? Like, and you tend to see this all the time where the elasticity is very different for the same product for a distributor versus the end customer, right? You also tend to see it, especially for products that are like large ticket products that are financed by the end customers. You tend to see where you do promotions and things like that. There's a ton of like buying by the distributor, and guess what? Like you would hope that they would actually pass on the promotion to the end customer. And many times during like naturally highly seasonal environments where the customer is just going to buy the product anyway, maybe because they need to take advantage of some tax write-off towards the end of the year. The distributor doesn't pass it on, right? They just take the promotional investment and pocket it. That's a very sort of prevalent thing that happens in industry that a lot of manufacturers just don't have a really good solution for, right? And so I think that's why we're someone asked about the industry margin pools. It's really important to kind of couple that kind of supply chain level price elasticity for the different players to couple that with industry margin pools, and just really understand by like quarter, by time of year, by by customer segment or by distributor, right? Who's playing well versus who's actually doing some arbitrage with your promotional investments. Somebody's asking a question. Sometimes in pricing we have challenges with change management. Oh man, that's like, yeah, it's like 80% of kind of pricing transformations is just that. Can we use ChatGPT for change management tools or models? I don't know. I don't have a good answer for that. I mean, what I'll do, I think you can use it to sort of help frame out the plan that you want to do. But at the end of the day, at least in my experience, and I've never been sort of a change management leader, but it really comes down to human to human interactions. It really comes down to collaboration, right? If you're trying to build a new pricing process or a new tool, etc., you want to have people from the commercial teams, right? Sales, brand, finance, actually along the journey and kind of co-build and co-architect these solutions or these strategies with you. Like that's always been, the thing that has really worked for me in the past. Like, early on, honestly, for like the first 10 years of my career, I try to do things in a vacuum because I thought, hey, me and my pricing team or me and my data science team are smarter than everybody else. Like we don't need, sales to sort of get in the way. And like 100% of the time, the things just failed, right? Because they were never sort of utilized or adopted. And so, but what I'd love to do is I would love to actually like pose that question to somebody who's actually in change management and see what their response is. Somebody's asking, what are examples of errors, hallucinations you need to look out for? Yeah, I mean, I think, it's a really good question. This is where you have to have, sort of the domain expertise, and it's helpful to have some coding experience. So a lot of the times you tend to, especially when you're asking the GPT-4, right, to kind of give you insights or recommendations, sometimes they'll just make stuff up, right? And so, if you have that particular domain experience, like you've done revenue management for the last 15 years, like you'll be able to easily pick that out, right? But if I'm honest with you guys, like most of the time, like even those hallucinations are like not that much different than like executive decks that you may have seen from like blue chip consulting firms that are like fairly kind of ambiguous and generic with like little specificity. And so again, like you'll be able to kind of sniff that out really easily, especially if it's like super generic and like uses like sensationalist language and things like that. That's kind of the telltale sign. And the last question, if you have more, have time for one more question. But last question: if you're using sample or dummy data to feed into GPT to get the code and then run the code later on your real data away from GPT, does this mean that this is applicable only for using Python or R and not really Excel-based analysis? Yeah, I mean, I think for modeling, it certainly works, right? Because for modeling, right? I mean, for most models, you're trying to sort of optimize certain hyperparameters in the model. And so, whatever ChatGPT tells you is the right model, anyways, you're going to rerun the model with real data, and you're going to get just like a different model with different weights and different results, right? So I think it's fine to do that. Excel, I mean, I can't imagine, what you would use it for Excel other than, maybe like visual basic scripts to like automate certain kind of repetitive things, repetitive copy paste or whatever else, or repetitive inputs, or using it for formula. And then honestly, like in that case, it would still work, so long as you kind of, provide the same kind of, variable names and column names and field names and things like that, right? Really good questions, guys. Well, listen, if you don't have any more questions, I'll send this content out. I'll also send kind of the GPT generated code for the models that I've had to modify because there were a couple of hallucinations there. Back to your question, so I'll share that with you guys, and then really appreciate the engagement. I thought this was a really good session as usual. And then last question, maybe somebody is asking, how frequently should cohort analysis be performed to ensure its relevance and usefulness? I would say you do it, I don't know, a couple of times a year is when you kind of do a review process, or maybe do it quarterly, no more frequently than that, right? If you do it quarterly, right, you can kind of see how your retention is doing year to date, comparing it to year to date last year, right? Or if you're doing it like midway through the year, you're going to get a sense of how you're trending and where you need to make adjustments mid-year for your sales strategy or customer engagement strategy, right? Good question. Guys, appreciate the time. Let me know if there's any questions, but otherwise I'll catch you at the next AdLib webinar that I do. And you guys enjoy the weekend, and hope to talk to you soon. Thank you.